Hello, my name's R2-Z2, and this here is my project that I've been working on. It is a self-balancing robot, and that's what I had in part one. And part two here, I just want to describe all the various parts and pieces to this robot. Its basic chassis is modeled after the Balanduino, and that you can find on balanduino.net. Hi, R2-Z2 again. Okay, now I'm going to go over the parts and pieces of the self-balancing robot. It pretty much has no capability of going forward or backward right now. That I will be adding in. For my remote control car, I took out the RC portion, and that would be this. And I will be putting this on the robot and be able to control it via here. So let me get into the parts and pieces here. It's the basics. Let's see if we can get a good shot. Right here, this is the brains of it. This is the Arduino Uno. Actually, this is SaneSmart's version, which is the SaneSmart Uno, and they do a great job of adding in these extra headers, so you can tap off of these depending on the type of connector you have, whether it's a male connector or a female connector, and you can also get a row of VCC and ground. And the other nice thing is they have a switch so that you're able to switch between 3.3 volts and 5 volts. That's important because a lot of the electronic components today that are coming out are 3.3 volts based, and this here is the IMU, which is the MPU 6050, and this also comes from SaneSmart. And this runs at 3.3 volts, and it communicates to the Uno via the I2C bus. And then I have a battery, relatively small, but it's 12 volts and gives up to 2 amps, which is plenty for this, and just power distribution on and off connector I put on there. And the only other part really is the motor controller, and this is the DM25. It actually has a PIC chip, so you write. I set up a software port on the Uno so that it's able to talk to this board, and it sends commands, and it can read data. It can read the encoder. These are the encoders on the motors, and then it also sends the speed. You can also set it to accelerate at a certain rate. That I don't really use right now because it's a little too sluggish, but once I get into the forward motion and reverse and turning and stuff, I probably will use that. So that's a nice capability to have. So pretty much what's needed on the Uno is a filter of some kind. In this case, I'm using a Kalman filter that comes directly from the balanduino.net website. So that's openware that they have, and theirs is really good. It doesn't drift as much as some other ones. And so the data from the accelerometer gyroscope feeds in, it's read, and then it goes through the Kalman filter, coming up with the pitch. And from that, it derives through a PID controller that I made up for this to be able to control the speed of the board. So it comes up with a value depending whether it's going forward or backward between 1 or 0 and 127, and that goes from off to full speed. So that's pretty much it. I had to put a little smoothing algorithm into the output of the Kalman filter because it was noisy to the right of the decimal, and when you're multiplying in the PID controller, that does get amplified, so I do some smoothing out. So that's the prototype right now. I'm going to be adding a lot of different things to it shortly. I will be putting on that module so that I can control it to go forward and backward. That should be interesting to see exactly how I'm going to get that to work. Not the module, but being able to get the right angle and accelerate without it either, flying backwards or falling forwards. So that'll be in my part 3. That'll be up and coming. All right, thank you.